Manufactured parts must fall within a specified tolerance around the target dimension. Process measurements scatter around this target. The spread of those measurements determines how many parts fall outside the tolerance band. Variance is measured in squared units of the dimension, not in the unit of the part itself. Standard deviation is defined as the square root of the process variance. It restores the unit of the original dimension. Process capability is expressed as the mean plus or minus 3 standard deviations, the natural spread in the original unit. This is the operationally interpretable measure of process spread. Statistical process control tracks standard deviation over time through successive production runs. Standard deviation measures the typical magnitude of deviations from the process mean, treating upward and downward variation symmetrically. It summarizes the scale of variation, not its direction or position relative to specification limits. Two processes can have identical standard deviations while producing very different conformance rates. One is centered within specification limits, the other has drifted toward a boundary. Standard deviation and variance contain the same information. Knowing one determines the other. Neither detects the position of the mean relative to specifications. Standard deviation is not sensitive to a shifting mean. A process whose mean drifts toward a specification limit can maintain a stable standard deviation throughout the drift. A small standard deviation describes typical scatter around the current mean. It does not signal that the mean itself is approaching a failure boundary. Standard deviation improves on variance by expressing process spread in the original unit of the part dimension, but it inherits all of variance's structural limitations. It cannot distinguish random scatter from patterned variation, cannot detect correlation across successive outputs, and cannot locate where defects cluster in the output space.